We now talk about Gauss's law of magnetism. So this law simply states that the net magnetic field through any closed area is 0. So you can see that the line integral of the magnetic field with the small area, so this is a dot product here, this is equal to 0. So basically it says that the number of lines entering the surface equals the number of lines leaving the surface. Therefore, the net magnetic flux is 0. Now, this is not the same as electric flux, as we will soon see. So look at this example of a magnet. So number of lines leaving the North Pole is equal to the number of lines entering the South Pole. So the number of lines leaving the magnet is same as the number of lines going into the magnet. So net flux is 0. So basically it means is that there are no isolated North Poles. So you cannot have an isolated North Pole that only lines are coming out of it. So that is the Gauss's law, that there are no isolated poles, or this is called monopoles. Secondly, notice that if you place some body like this in the magnetic field, the number of lines entering the body is same as the number of lines leaving the body. So now you can see again the magnetic flux for a body placed inside a magnetic field is also 0. Now we said before that this is not the case with electric flux. So say you have a negative charge. So if you have a negative charge like this, and say you have placed it in some surface like this, the lines come into the negative charge. So the electric field lines always come to the negative charge from all directions. So there is only negative charge inside the surface. So all the field lines are coming in. Nothing is going out. So you can see the net electric flux is not 0 here, since there is no line going out. So notice that there is a difference between magnetic flux and electric flux. In magnetic flux, the number of lines entering is equal to number of lines leaving. This may or may not be true for electric flux.